Hello, this is Geometry Notes 2-8 Angle Proofs with Mrs. Moslick. I want to let you know that in these notes, we're mostly looking for justifications once you're given some important information in Chapter 2. So to start with, let's look at our chart. On the left side, we're given that B is the midpoint of AC. So in general, if you're given a word, almost always you're going to use definition of that word for your justification. We know from chapter 1 that midpoint means that it cuts the segment into two equal pieces. So if they give you that B is the midpoint, then we know that the two segments have the same measure by the definition of midpoint. Now, we also know from chapter 1 that if we're given the word between, we're not going to use definition of between. We just know that somewhere in between in that line segment between A and C, there's this point B. And these two pieces of this segment add up to the total. So we're going to be using the segment addition postulate. In chapter 1, I started telling you to get used to writing that down. Two pieces or more equals the total line segment length. Now, the next two are angles. So two angles add to the total. That would be the angle addition postulate. Or if they are adjacent, remember what that word adjacent means is that those are just two angles that are next to each other. They don't have to have the same measure. They just will add to get this total. Like, so measure of angle 1 plus measure of angle 2 equals measure of angle 3. Adjacent means two angles that share the same vertex and share a common side. So far, none of this is new other than if you are given the word midpoint, use definition of midpoint for your equation. The next one is angle bisector. We've used that vocabulary before in chapter 1. Angle bisector means a ray or a line segment that cuts an angle into two equal segments. So bisector is just, it cuts it into two equal pieces, and this is angle. So definition of angle bisector. You could also be given a segment bisector. And so if you're given a segment bisector, it would be like midpoint. You would just use definition of segment bisector. So if B is the segment bisector of AC, by definition of segment bisector, those two are equal to each other. So in general, if they give you the words, usually say definition of that word. The next two are vertical angles. We know that if you have two line segments, or lines or rays that intersect each other, we are given opposite angles, and opposite angles are always equal in measure. So we have two pairs of equal measured angles. And so by the vertical angle theorem, those measures are equal to each other. It doesn't matter if they give you a picture or if they give you the words here, you just use the vertical angle theorem. The definition of vertical angles just tells you what they are. They don't tell you that the measures are equal. So here you have to use the vertical angle theorem. If you write down vertical angle theorem once on your side of your sheet of paper, after that you can write VAT. Okay, so that's all review pretty much. Backside is almost all review as well. We're going to review complementary and supplementary angles. Remember, complementary looks like a 90 degrees. So complementary are angles that add to 90 degrees. So if they give you the word complementary, just use the definition of that word for complementary. If they give you anything else like perpendicular or the symbol for perpendicular or a right angle or the picture of a right angle, then just use the complement theorem. So again, for the next four, these are all examples where they are going to add to 90 degrees by the complement theorem. You only use definition of complementary if they give you the word complementary. So the first five, the equations are all equal to 90. Mostly you'll have complement theorem unless they give you the word complementary. If they give you the word supplementary, just use definition of supplementary. Again, supplementary, that S almost looks like an 8. So 180, one way to remember that supplementary angles add to 180 degrees. And lastly, if angles form a linear pair or you're given a picture of a linear pair, then by the supplement theorem, their measures add to 180. If I give you a picture like this from the bottom left, if I ask you what is that angle pair, you would say they are a linear pair. Now they are supplementary and they are adjacent, but the best vocabulary word is linear pair for this picture. By the supplement theorem, they add to 180, but the actual angles themselves form a linear pair. That's all I have to teach you in notes. So let's do some review. So I am going to go to a warm-up review sheet. This is warm-up chapter 2, number 2. It says label each picture, write an equation, and justify. We're not going to solve. Now, these are problems from 2.8 skills practice and 2.8 practice. But what I want us to do in this warm-up sheet is just to set up an equation, and we are not going to solve it, but we want to work on our justifications. So this is chapter 2, justifications are important. So first of all, measure of angle 2 is 57, and we know that those are a linear pair, but by the supplement theorem, their measures add to 180 degrees. So measure of angle 1 plus 57 degrees equals 180. We're not going to solve, we just want to set this up. So again, the angle 1 and 2 form a linear pair, but by the supplement theorem, they add to 180. Next one, number 2. We are given that measure of angle 5 is 22. Note that I am marking up my picture. Since this is a right angle, we know this is also a right angle. So measure of angle 22 plus 6, sorry, not measure of angle 22. I would just say 22 degrees plus the measure of angle 6 is 90 degrees. Since they form a right angle, that would be the complement theorem. I'm not using definition of complementary because they don't give us the word complementary theorem. So this is just by the complement theorem. Next one, measure of angle 1 is 38, and we know that 2 is a vertical angle to it. So by the vertical angle theorem, now this is the first time we're writing vertical angle theorem down, so you can't just write down that, write down vertical angle theorem. Feel free to write THM, or also feel free to use the symbol for angle, but write out the word vertical angle theorem. So 38 degrees equals the measure of angle 2. Now notice our equations are either going to add something, add to get something, like add to get 180, add to get 90, or they are going to equal each other like the vertical angle theorem. Moving on to number 4. 13 and 14 form a linear pair. So that's the vocabulary word for 13 and 14. But their measures add up to 180 is by the supplement theorem. So this is the supplement theorem. Yes, they are supplementary, so they add to 180 degrees. And so we can mark up our picture. You would eventually solve for x, but right now we just want to get to know the justifications. So 13 and 14 form a linear pair, and by the supplement theorem, they add up to 180. Now, number 5, they're using the word complementary, so we're going to use definition of complementary for our justification. Definition of complementary. And since we are given that 9 and 10 are complementary, they're going to add to 180. We also know that 7 and 9 are the same. Let's just call them x. And 8's measure is 41 degrees. So if this is 90, this is also 90. So we can say x plus 41 degrees equals 90 degrees. That's by the definition of complementary. You could also use the supplement theorem since we found out that if this is 90, this is also 90. So you could also say by the supplement theorem that we kind of need both of those justifications, because we knew that this was 90, and the only reason why I know this is 90 is because they add to 180 by the supplement theorem. So I need definition of complementary and the supplement theorem here. Next side, we have 2 and 3, we know those are vertical angles, so their measures are equal to each other. Measure of angle 2 equals measure of angle 3. So I marked that up here, and this is by the vertical angle theorem. Now I'm on the back side, so I have not written that yet, so we have to write down vertical angle theorem. Feel free to just use the symbol for angle and THM for theorem. Number 7, 1 and 2. Now 1 and 2 form a line, so they are a linear pair. That is the definition or the vocabulary of angles 1 and 2.